Hello everyone, welcome back to my channel. I am Vihan, a perfect AB Precal 5 kid. I took the test when I was in 9th grade and I got a perfect 5. I am currently in 11th grade and I have started this video series since last year. Now I know that College Board does not give out the official multiple choice practice of AP Precal, and I was one of the first kids to have sat for this test the first time it was introduced. So I know exactly what questions they asked me on my multiple choice. So although I have made these questions on my own, I can guarantee you that these are very much relevant to your test. I have a total of 35 questions with me and I'll be having them in 5 videos of 7 questions each. So if you like the videos and if you feel that you want to look at all 35 of them, make sure that you watch all 5 videos. Apart from that, the entire 35 question PDF along with the answer key is linked in the description below. If you do choose to directly go to the PDF instead of looking at the video, I would really appreciate if you leave a like or a comment. It would really help me since I'm applying to college as well. Yeah, so let's begin. Okay, question 1. Which of the following functions has a domain of all real numbers greater than 0? Now I want you to focus on the domain that is mentioned here. All real numbers greater than 0 implies x strictly greater than 0. This does not mean x greater than equal to 0. This is not something we're looking for. So we have a few distinct terms here. We have x squared, we have root x, we have log x. Now for x squared, the domain is all real numbers. Reals all. Yeah. So even if we have minus 1 square, it is defined to be 1. So we can't have option C or option D. Now if you think carefully about root x, we know that the square root of 0 is defined to be 0, right? So our domain essentially includes x equal to 0 as well. But the domain that they want in the question is x strictly greater than 0, which means that we can't have a standalone square root x as well. So you won't have option A. Ideally, we'll be left with option B. And if you look at it, we have log x and log 0 is not defined. We can't raise any number to any power to get 0. So essentially the domain of this entire function becomes x greater than 0, although we have a root x in here because log x isn't defined for x equal to 0. So the correct answer here is option B. Okay, you can pause the video right now and have a shot at this question. So the question we have is, which of the following equations does not define y as a function of x? Yeah, first of all, it is important to recall the definition of a function. A function is when each input has one distinct output. So for example, if you look at this graph, if we take some arbitrary point, say this one, yeah, it has one output here and one output here. It has two outputs at one input, which means this is not a function. Yeah, so I've rewritten option A, C and D, and you'll see that all of them, yeah, for a value of x equal to 1, option A always gives y is equal to 63. There is no possibility of having another answer as the output. But if you look at option B, yeah, if we rewrite this, we have y square is equal to 64 minus x, which implies y is equal to plus or minus square root 64 minus x. Now the biggest misconception that all people have is that y is equal to square root x and y square is equal to x are the same function. No, they are not the same function. Y square equal to x implies y can be equal to plus or minus root x, because if you square minus root x, you'll get x square, and if you square positive root x, you'll get x square. But in the case of y is equal to root x, you only get the positive value. In this one, you only get the positive output. So an important concept for you to clear is that y equal to root x and y square equal to x are two different functions. So for instance, if I had my option B to be y is equal to square root 64 minus x, this is a function. But since it's y square is equal to 64 minus x, it isn't a function. Since if I take x equal to 1, I may have minus square root 63 or I may have plus square root 63. Exactly the phenomena we discussed here, where we have one input and two distinct outputs. So that is not a function, and hence our correct answer is option B. Here is the next question. You can pause the video and have a go at it. Okay, we have the graph of a function and we need to find a possible expression for the function. Now I hope we're all aware of this concept that if we have a graph which is tangent to the x-axis, its root is even multiplicity, and if it crosses the x-axis, we have it as an odd multiplicity. So if we look at the graph here, yeah, x plus 3 is one factor, x plus 1 is a factor, and x minus 2 is a factor. Now at x equal to minus 1, or the factor x plus 1, we have the graph to be tangent, so the multiplicity is even, so 2, 4, 6, 8, I'll keep 2 for now. If you look at the other 2 points, they cross the x-axis, which means I have an odd multiplicity, possibly 1 for now. Yeah, so our function should have x plus 1 whole square and x plus 3 and x minus 2. Now if I observe my option choices, we have x plus 3 whole square, we don't need this one, so this isn't the answer. X plus 3 whole square, we don't need this one. If I look at these two, I have x minus 2 whole square, we don't need this one, so option B. Yeah, x plus 3 power 1, x minus 2 power 1, and x plus 1 whole square. The important thing here was knowing this concept, so if you're thorough with this one, this is a really easy question. Here is question number 4. Have a shot at it. Pause the video. Okay, now if you're looking at this table for the first time, I strongly urge you to take a screenshot, write it out in your notebook or whatever you want to do. You must memorize this table because I guarantee you 200% they will ask you on the multiple choice part, I bet you. And if you have this table, this question becomes very easy. So polynomial function has a negative leading coefficient. Okay, leading coefficient, this is the row we're concerned with. As x goes to negative infinity, okay, the values of f of x go to positive infinity. So the last row is the one we're concerned with. Which of the following must be true? Okay, so we notice that the degree is odd. Yeah, so f of f has an odd degree, so we'll cancel out the even ones. F has an odd degree. Yeah, now we have to read this one carefully. Yeah, option B says if f of x goes to negative infinity, then x must be approaching positive infinity. So if we analyze this one, yeah, as x goes to negative infinity, our x is actually going to positive infinity. So we look at this row, yeah, as our function approaches negative infinity, our x does approach positive infinity, so B should be the one. If you look at D once more, if our function approaches positive infinity, then x, which means if our function approaches positive infinity, our x should be approaching positive infinity as well, but that is not the case. We have a negative infinity, so option D is not the correct one. Option B is the correct one. Again, memorize the table. Question number 5. Pause the video and have a shot at this one. Again, for this question, it is important to realize that it is a limits question, and the values of the table are just important for us to get a scaffolding of what is the end behavior. So if you notice that as x approaches towards negative infinity, like negative 100 and then negative 1000, the values of g of x go increasingly negative. So similar is with the positive direction. As x gets increasingly positive, g of x gets increasingly positive. So our limit as x approaches negative infinity is negative infinity, and as x approaches positive infinity is positive infinity. Now again, the table is of utmost importance. Yeah, so what do we have here? Okay, we have if we refer to this one, yeah, x approaching positive infinity, we have positive infinity, and negative going to negative. So the second row is what we're concerned with. Yeah, this one, the second row. So we must have a positive leading coefficient. Okay, leading coefficient positive, I don't want you. Leading coefficient positive, I don't want you. It's either B or D. What else do we have? We have a degree odd. Yeah, I want an odd degree. This is even, I don't need you. Odd degree, yes, you should be fine. So D is the correct option. Again, I emphasize, knowing the table solves a lot of questions. Here is question 6. Pause the video, have a try. Again, this question, like the table one, is very important. This will 200% appear on your test. I got 3 of them, and believe me, I was lucky that I knew this one. So I hope all of us know the way to start this one is that you move 2x to the other end. You pull out an x and then you factor it with whatever factoring methods you're comfortable with. It is the steps after these that are a bit non-trivial. So till here, all of us know that we have we have a 0 at x equal to 0, we have a 0 at 1 by 3 equal to x, and we have a 0 at minus 2 is equal to x. And these are the points where our function becomes 0. Yeah. So next step I want you to do is I want you to draw a line. Yeah. Just draw a random line and plot the 3 points on the number line as they appear. Forget about the scale, forget about the magnitude, just plot 3 points at a good distance. So we have -2, I have 0, and I have 1 over 3. And now I want you to mark 4 intervals. Yeah. So this is interval 1, interval 2, interval 3, interval 4. Now keep in mind our goal is to make the function negative. Yeah. Our inequality says that we want the function to be negative less than 0. Now the next step after this is to test exactly one value in each of these intervals, and that one value will be the representative of the sign the entire interval takes. So for example, I'll begin with the leftmost interval, which is -infinity to -2, and make sure that you pick a very comfortable test value such that you don't have large calculations. And one more important thing, you're only concerned with the sign, you're not concerned with the magnitude of the answer. So here I'll pick in the leftmost interval, I'll pick my test value to be x equal to -3 again. So if we look at here, we have 3 terms, x, 3x minus 1 and x plus 2. Yeah. If I put an x equal to -3, I get negative into -10, which is negative, into -1, which is negative. So this value should be negative. Yeah. So this interval is negative. For -2 to 0, I'll pick x equal to -1. That should give me a negative into a negative into a positive, which will end up being positive. So this interval is positive. If I look at 0 to 1 by 3, I'll have to go with, let's say, 1 by 4. So my first term will stay positive, second one will become negative, the last one will become positive. So this entire interval is negative. And if I look at the last one, I'll pick x equal to 1. So I have a positive into a positive into a positive, which is positive. And what are we looking for? We're looking for a negative value. So ideally, wait, I'll finish this plus. Yeah, we're looking for a negative value. So this interval and this interval should be our answer. So we want -infinity to -2. Alright, I see a -infinity to -2, so I'll cancel these, and I need a 0 to 1 by 3. 0 to 1 by 3, yes, I see it here. This isn't what I need, so the correct answer is option A. Again, I emphasize this question will appear on your multiple choice, so it is important that you understand how to solve these. Alright, question number 7, have a go at it. Now in questions where you have a polynomial function with 2 variables a and b, and if you have 2 factors or 3 factors, you have to recall the factor theorem, which says that if x minus a is a factor of your function f of x, then f of a is equal to 0. Yeah, this is something important which you must know. So since x minus 2 and x plus 3 are factors, we have f of 2 to be 0 and f of minus 3 to be 0. You then plug the values of 2 and minus 3 in, and you get 2 simultaneous equations, this one and this one. Now I would recommend that you solve it using whatever ways you are comfortable with. but to me it's pretty clear here that a should be 0 and b should be 6. So the value of a plus b is equal to 6, and C is our answer.